over a big area, that duct's got to be able to withstand it. I like to do a demonstration from time to time on a pretty good sized door that has about a 1-inch water column of pressure on it, and crank up the fan and have someone to hold it there. Well, you've got to measure that 1 inch for every square, 1 inch of water pressure for every square inch there. When you add it up, if it's a good sized door, it's going to take a lot of pressure to hold it closed. That duct has to be able to withstand that. Okay. We don't use a whole lot of mercury U-tubes anymore, mercury being what it is, but we can use U-tubes using fluids other than mercury to measure pressures also, lower pressures. Now, I didn't bring too many pipe tools out, but this would be used when you're hooking up gas lines or iron pipe. The teeth, great for that type of work. For copper, don't use this. Okay? For brass fittings, don't use this. As a matter of fact, don't use anything that has teeth in it on those soft metals. It will take the metal away and leave places that can cause problems in the future. You'll have other tools that you use that's just standard tools, Phillips screwdrivers, combination screwdrivers that may have different tips, Phillips, straight, 5/16, 1/4 inch. The 5/16 and 1/4 are probably the most common. You'll see other tools that's very common, open end wrenches, combination wrenches, which also has a boxed end. But some of the special tools that you'll see are specially designed for flares. You notice that it can't be classified as a closed or boxed end, nor can it be classified as an open, but it takes much more grip, it gives much more grip to the flare fitting itself. I always like to kid around a little bit. Very important too. Can be used for a lot of things. A frustration factor.
We used to fix machines at General Motors with that.
That's the best tool. You know, really, it is a grand tool, no doubt. It can, like anything else, this can be used the same way. No. But that's like they say, a little misuse of tools. But most folks don't realize that an adjustable wrench actually has direction on it. You should actually be pulling in this direction, not this way. When you pull in this way, it puts stress on the adjustable side itself, and it won't grip as well. So you want to pull in that direction. Okay? You know, we measure pressures, and no doubt about it, we measure pressures of all kinds. And one in particular is we're going to have to learn how to use a micron gauge. Microns, well, you've been taught that a perfect vacuum would be about 29.98 inches of mercury. Okay, or if you would absolute zero, or you would have a grand total of minus 14.7 pounds of pressure if you were looking at absolute. Well, let's talk microns. How about let's round it off, say 15 pounds, and now divide that 15 pounds by 799,000. Now you got 1 micron. So this is a very accurate way of measuring vacuums. It is really the only way that you can tell that you have got a complete vacuum or a good vacuum when you evacuate a system to know that the moisture and all is gone from the system. All right. You know, I left something out that we definitely got to have in the HVACR industry, and that's something to measure temperature. This is an infrared. Very good, but not good. Okay, why did I say that? It's very good for getting spot, quick temperatures, such as a vent, a register, or an object. But if I want to measure a piece of pipe, that's not good. If I want a precise measurement, this takes too much of an area to get a precise measurement of an object. good overall, but not precise. So how do we do that? Well, we do that with other instruments, such as a probe such as that. There are also some pipe probes that would actually wrap around a suction line, for example, and you would use an electronic readout. Doesn't have to be electronic, but you see the little pocket thermometers? They're not bad if they're calibrated and correct. It's kind of hard to get to them to read them sometimes, but they're okay. There's also some attachments that would go to a multimeter for reading temperatures. Okay, a multimeter, call that because it can read voltage, AC or DC. This particular one also has a capacitance checker built into it. With the proper attachments, you can also read amperage and temperatures. Okay, very nice. Here's one that a clamp on can measure amp draw. Okay, you know, what kind of meters do you need in this field? You definitely need something such as this. It doesn't have to be this brand, but you definitely need something good. When it comes to measuring anything, temperature, pressures, voltages, amperages, make sure you get something that's dependable. Okay, if you don't have something that you can trust, especially with a voltmeter, your life is dependent on that. Now, that sounds pretty extreme, but it's true. If you have a voltmeter that's not reading correctly and you test something and it shows that there's nothing there, you think it's safe. And you go to stick your hand in it, you may get a bad surprise. Okay. Some of the other instruments I was talking about, this is one, looks like spaghetti right here, but there's some tubes that come out of there. This is for measuring pressures in a duct. Okay, we would actually hook up the two tubes to the line. We can measure very, very low pressures, fractions of an inch of water column. A couple other instruments that we're going to conclude here in just a moment. This day and time, with the cost of refrigerants, we don't want them leaking out. Electronic leak detector. Okay, how sensitive is that? Should be able to pick up a rate of less than a quarter inch a year. A leak rate of less than a quarter inch a year. Sometimes you'll actually have enough residual in a hose to pick it up. I was hoping it would do that. Let's try it again. You hear it pick up there? That's residual within the hose itself. Here's a problem though. You know, cost-wise, I'm going to get lost on that one. Because different brands and different bells and whistles, if you will. Of course, the more bells and whistles, the more it's going to cost. I always like to say that you're probably going to be looking at most of these instrumentations up here somewhere between 100 and 300. That seems to be the range, and that's a big range, but it depends on what it is.
And that's per tool, right?
Yeah, that's per tool. You know,
thought you had a good deal going there.
Yeah. One thing about this work, it's expensive to get in tool-wise, but it also pays pretty good. Now, at the same time, I can tell you this firsthand. You never have enough instruments and tools. When you think that you got everything that you ever needed, you're going to find out you're going to need something else. That's just the name of the game. Yes?
Some of these specialized tools, would they be checked out, I guess, from your employer on the day that you may need something like that?
Absolutely.
You'd be responsible for the nuts or the wrenches and the multimeter and things like that.
Now, good question. I can't answer what every employer would do. I can tell you generally, though, most employers are going to expect you to have the basic tools. They're going to expect you to probably have multimeters, possibly temperature tools such as that, or instrumentation. Some companies would want you to have things such as a vacuum pump or torch set. Some companies may actually furnish you or let you check out, if you will, vacuum pumps, recovery units, things such as that. It depends upon the company, very much so. Most employers realize, though, that you're working for them and they're going to furnish you the major tools. You know, let me say this about the tools, though. Even if it's company issue, if you're issued a truck, remember somebody had to buy that truck. Sometimes we get into company vehicles and treat them a lot different than what we would our own. So treat their things as if it was your own. There's been some horror stories about that, and some real bad feelings that have happened in the field where people misuse